I'm recording y'all's lesson today because y'all are a fantastic class. And I always record first period, and y'all never get to be the raucous crowd in the background cheering. With today, y'all can be that class. All right, list all six trig functions for theta equals 2 pi thirds. We're kind of leaving degrees behind at this point, although they're still around, and we're going to start using radians almost exclusively. So first thing that you want to do, this is how I do it, and feel free to adopt my method. When I see 2 pi thirds, the first thing I see is pi thirds, okay? And I know that all pi thirds angles, every angle that has a pi thirds in it, question pi thirds, is going to be the ordered pair 1/2 square root of 3/2 plus or minus. Could be positive, could be negative. But I know the pi thirds is your 60-degree reference angle. That's where the triangle is taller than it is wide. So the sine, the y, is bigger than the x. Okay? It's the 1/2 square root of 3/2. Now, the 2 tells me what quadrant I'm in. 2 is less than 3. If you notice up here on the unit circle, let's do this real quickly. All of the coefficients in quadrant 1 on the pi are 1s, right? That's easy to remember. 1, 1, 1. What do you notice about quadrant 2, the numerators compared to the denominators? What do you notice in comparison to their numerators and denominators? 2, 3, 3, 4, 5, 6. The numerators are 1 smaller than the denominator, right? That tells you what quadrant you're in, because pi is the x-axis. When you get to pi, you get to 6 pi 6, or 4 pi 4ths, or 3 pi thirds. So if you're just short of that, 5 pi 6, 3 pi 4ths, 2 pi thirds, you're in quadrant 2, where x is negative and y is positive. What do you notice about quadrant 3, the numerators compared to the denominators? They're 1 bigger. So yeah, when you are just past pi, when the numerator is just 1 bigger than the denominator, you've rotated past pi a little bit into quadrant 3, where both of them are negative. And then these are kind of the ones that stand out like a sore thumb, 11, 7, 5. But here's another way to remember it. The numerators are 1 less than twice the denominator. So instead of 12, it's 11. Instead of 8, it's 7. Instead of 6, it's 5. They're 1 less than twice the denominator. And if you can recognize those coefficients, you know you're in quadrant 4, where x is positive and y is negative. Okay? And once you know all six, once you know x and y, then you know all the other 4. Okay, so where does 2 pi thirds tell us to be? 2 is less than 3, so we're 1 short of pi in quadrant 2, where it's left and up. Left and up means that it's negative x and positive y. Would you agree? Okay, now that I have my ordered pair with the correct SIGN sign, I can start listing them. Here we go. Sine of 2 pi thirds. I'm going to actually write the angle. Sine of 2 pi thirds is just the y value there, isn't it? What's the y value there? Square root of 3 over 2. Yeah, there's the sine of 2 pi thirds. What's the cosine of 2 pi thirds? Negative 1/2. Very good. What would be the tangent of 2 pi thirds? Well, that's y over x, isn't it? This is x and this is y. Y over x, so that's going to be negative square root of 3. Good. We practiced this the other day. So it's the same thing. The 2's are going to divide out. Whenever you do tangent or cotangent, your 2's divide out from the denominator. Okay? Now we just list the reciprocals. Cosecant of 2 pi thirds. That's just the reciprocal of sine. That's the reciprocal of the y values. So that's the reciprocal of the square root of 3 over 2, which when we flip it and rationalize it, we get what? 2 square root of 3 over 3. Yeah, 2 root 3 over 3. These ratios you become intimately familiar with as you practice more and more and more. All right, secant of 2 pi thirds, that's the reciprocal of cosine. That's the reciprocal of x. That's going to be negative 2. Cotangent of 2 pi thirds, that's the reciprocal of tangent, or x over y, whatever you want to call it. Negative 1 over root 3, which when we rationalize it is negative root 3 over 3. Yeah, and there they are. There's all 6 trig functions for 2 pi thirds. Okay, 2 pi thirds happens to be the same angle as 120 degrees. So this could easily have been what are all of them for 120 degrees. In fact, they're equal. It's just different units, right? Different units. But we're not going to be using degrees anymore. We're going to stick with radians. Radians are going to actually be easier. You're going to like radians more. Okay, any questions on the warm-up? So you saw yesterday how the video created all these numbers. Tomorrow you're going to have a quiz where I'm going to give this to you, and you're going to have 5 minutes to fill in all this information. And we're going to practice that together at the end of class. We did it in about 4 minutes last period, which is a minute to spare. But we're going to do that at the end of class, okay? Um, let's go ahead and finish the notes for today, okay? So if the x-coordinate is the cosine of the angle and the y-coordinate is the sine of the angle, then watch this. We can list the other four trig functions, not just in terms of x, y, and r, but in terms of sine and cosine. It's amazing. Every single trig function can be written in terms of sine and cosine. Tangent, which is still y over x, becomes what? Sine over cosine. This right here is what we call an identity. The left side is equal to the right side for all values in the domain. So it becomes a mathematical synonym. If you ever have tangent and you want to replace it with something that's just as equal to it, call it sine over cosine and vice versa. Okay? Tangent is sine over cosine. Cotangent, which is still x over y, is now cosine over sine. So that's an identity. If you're ever staring at cosine over sine, you can replace it with cotangent, and they're just as equal to each other. Okay? Of course, secant is the reciprocal of cosine, so it's still 1 over x, the reciprocal of the x-coordinate. But since the x-coordinate is cosine, it's 1 over cosine. Secant and cosine are reciprocals of each other. Secant is 1 over cosine. And similarly, cosecant, which is still 1 over y on the unit circle, is the reciprocal of sine. Cosecant and sine are reciprocals of each other. Okay? So we're going to be talking about identities exclusively later when we do trig proofs, and we're going to be using these fundamental identities and others that we learn to help us go from one expression to another expression, okay, by way of sine and cosine. So that's a remarkable feature right there. I just want you to appreciate it. All 6 trig functions can be written in terms of sine and cosine. Of course, sine and cosine can be written in terms of sine and cosine. We know that. But the other 4 can also be written exclusively in terms of sine and cosine. That's pretty nice. Okay, let's look at example 9. Using the unit circle, this is going to be like our warm-up. Find the 6 trig functions for the following angles. So this will be like our trig function, or warm-up, sorry. Theta is 5 pi fourths. So here's what I do. When I see 5 pi fourths, the first thing I see is pi fourths. That's the first thing I see. And anytime I have a blank pi fourths angle, I know it's going to be the square root of 2 halves, square root of 2 halves, plus or minus. It's going to be some type of square root of 2 halves, square root of 2 halves. Now I look at the 5, and I know that 5, which is bigger than 4, puts me into quadrant what? It puts me into quadrant 3. 5 is just bigger than 4, so I've rotated past pi. I'm in quadrant 3. And in quadrant 3, to get there, I have to go left and down. To get into quadrant 3, you go left and down, left and down. So they're both negative. You got it? That's how I do it. They're both negative. Now that we have the x and y, and we're staring at x and y, we should be able to list all 6 trig functions. Let's try it out. Sine of 5 pi fourths. You could write theta if you want, but I'm going to write 5 pi fourths every time, because when we take our quizzes starting on Thursday, all of your angles are going to be written with numbers instead of thetas. So sine of 5 pi fourths is what? Negative square root of 2 over 2. It's just the y value, right? Perfect. What's cosine of 5 pi fourths? It's the x-coordinate, which is the same, negative square root of 2 over 2. And because the x and y are the same, what's tangent of 5 pi fourths? 1. Anything divided by itself is 1. Yeah. All right, if we work our way out here, what's cosecant of 5 pi fourths? Well, cosecant is the reciprocal of sine. What's the reciprocal of negative root 2 over 2? Thank you, Carly. Negative root 2. We always have to take into consideration what the SIGN sign, plus or minus. And the reciprocal of a negative number is still a negative number. But we practiced the other day, or you should memorize the other day, the reciprocal of the square root of 2 over 2 is just the square root of 2. Yeah, and it still is. All right, so what's the secant of 5 pi fourths? Negative square root of 2. Yeah, negative square root of 2. And then finally, the cotangent of 5 pi fourths. It's x over y. That is 1. Yeah. Now, you'll see that when we start quizzing on Friday, I'm going to give you 10 random trig functions with 10 random angles like we were doing the other day in class, and you're going to have 10 minutes to fill out the right-hand side. So any one of these expressions, any one of these trig ratios or functions could be on your quiz on Friday when we do all of them, okay? Yes, yeah, you can do it like that. If you have room, do them as reciprocal columns. Yeah. All right, any questions on that one? Moving right along, dug-a-doon, dug-a-doon. Here comes 11 pi 6. The first thing I see when I see 11 pi 6 is the pi 6 part. I know that anytime I have a pi 6 over here, it's going to be square root of 3 halves, 1 half. That's your 30-degree reference angle. And that means that we're closer to the x-axis, so your triangle is wider than it is tall. So the x-coordinate is bigger than the y-coordinate. Okay. Now, the 11 tells me that I'm in quadrant what? I'm in quadrant 4. And to get to quadrant 4, we have to go right and down. So that's a positive root 3 over 2 and a negative 1 half. Okay, negative 1 half. So there's your x, there's your y. Here we go. Let's list them. Sine of 11 pi 6 is sine y. Jeremy, say it. Sine y. Yeah, that's not bad. You can work on it a little more. Cosine of 11 pi 6 is positive square root of 3 over 2. Yeah. Tangent of 11 pi 6. Now, for tangent, remember, it's still y over x. Not everything divides out, but the reason we rationalize the denominators is so that they all have the same number there. And that means the 2's can divide out. So tangent is really just the numerator of y over the numerator of x, which gives us what? Negative 1 over the square root of 3. Is that how we want to write it? No. So we rationalize it. We write it as negative root 3 over 3. Yeah. Guess what the reciprocal of square root of 3 over 3 is? Just the square root of 3. Very good. Yeah, I like root 2 over 2. Okay, I'm going to work my way out here. Cosecant of 11 pi 6 is the reciprocal of sine. What's the reciprocal of negative a half? Negative 2. Yeah. Secant of 11 pi 6 is the reciprocal of cosine. What's the reciprocal rationalized of root 3 over 2? 2 root 3 over 3. Yeah. Yeah, you're already getting familiar with that guy. All right. And then finally, cotangent of 11 pi 6. That's x over y, or at least we could say the numerator of x over the numerator of y, which is square root of 3. But what about the negative? Can we just toss it aside? No, it's negative. Yeah, we need to make sure we have the plus or minus correct. All right, there you go. There's all 6 trig functions for 11 pi 6. On Friday's quiz, any one of those 6 can show up. Any one of the 6, or any combination of the 6. On Friday's quiz? Yeah, I'll show you. We'll actually practice at the end of class. Yeah. Yeah. Okay, we'll actually practice tomorrow's quiz and we'll practice Friday's quiz or Thursday's quiz. Well, we're going to quiz every day. We quiz tomorrow and then we quiz on Thursday and then we quiz on Friday and then we quiz on Monday and then we quiz on Tuesday and possibly next Wednesday as well.
Are all of those taken this grade?
Yes, but I drop one at the end of the 9 weeks. All right. The time gets shorter and shorter on each of the quizzes too as we go. Tick tock goes the clock. All right, let's list all 6 for 3 pi fourths. The first thing I see when I see 3 pi fourths is, again, the pi fourths. I know that something pi fourths, whatever it is pi fourths, is going to be some type of square root of 2 halves, some type of square root of 2 halves. The 3 fourths, 3 being 1 less than 4, tells me that I land in quadrant what? 2. I'm not quite at pi. I'm in quadrant 2. And to get to quadrant 2, we have to go left and up. So that's negative, comma, positive. After teaching this for 25 years, I still don't have the unit circle memorized. I still assemble it the way I'm teaching you to do it right now. I can think through that pretty quickly, but I still assemble it the way I'm teaching you right now. All right, now that I have the x and the y, you can ask me any one of the 6 trig functions, and I can see that point visually in my head, or maybe in the beginning you're even writing it down and looking at it. Okay, we just listed it, right? Sine of 3 pi fourths is what? Square root of 2 over 2, yeah. Cosine of 3 pi fourths is negative square root of 2 over 2. Yeah. Tangent of 3 pi fourths is negative 1. That's y over x. They're the same magnitude, opposite sides. Cosecant of 3 pi fourths is square root of 2. Fantastic. Woohoo. Secant of 3 pi fourths is negative square root of 2. Yeah, we're rolling now. And then cotangent of 3 pi fourths, negative 1. Yeah, there they are. Any questions on how we generated those? We did those a little more quickly than usual. But remember, the reciprocal of root 2 over 2 is just root 2. There's a basketball game breaking out in the middle of pre-cal. All right, let's look at the last one here. 3 pi halves. Oh, ¿dónde está 3 pi halves? 3 pi halves is a quadrantal angle. It's 1.5 times around pi, or 3/4 of a full rotation. It's down here. It's the same as 270 degrees. The exact same as 270 degrees, just different units. What's the ordered pair straight down there at that quadrantal angle? 0, -1, yeah. So we can't forget the quadrantal angles. They don't land on the interior, so they're not as fun, but they still exist. And once we know the x and y, we can list all 6 trig functions for it. So let's go for it. What's sine of 3 pi halves? -1. What's cosine of 3 pi halves? 0. The y value and the x value. Yep. All right, let's try the others now. What's tangent of 3 pi halves? It's sine over cosine. It's y over x. It's -1 over 0, which we can't divide by 0. It's dne. Very good. All right, what's cosecant of 3 pi halves? It's the reciprocal of the y value, the sine value. -1. -1 is its own reciprocal. Very good. Secant of 3 pi halves. That's the reciprocal of cosine, which is the x-coordinate. The reciprocal of 0 is dne. Good. And the reciprocal of dne is 0. Awesome. All right, and then the last one here, cotangent of 3 pi halves. That's x over y, or cosine over sine. 0 divided by -1 is 0. Yeah.
I thought it was the opposite way around. Why is you can't put the 0 in the denominator, can you?
0 in the denominator is no good. 0 in the top alone is okay. 0 in the top is 0. So the cotangent, which is 0 over -1, is 0. But the tangent, which is -1 over 0, that's some type of infinity. That doesn't work. All right. Again, when we quiz on Friday, which is going to be over all 6 trig functions, any one of those could be on your quiz. So what your quiz is going to look like on Friday, and we'll actually look at a sample of it later. But just take, we got 1, 2, 3, we got 24 trig functions listed right there. Just take any random 10 of them and put them on a piece of paper. That's going to be your quiz. Okay. Plus, there might be other angles too, right? There's a lot more angles on the unit circle than these. All right, now here's the theorem. We can expand the power of the unit circle because of this theorem. Not only does the unit circle give us the exact trig values for all of the angles that we see on the unit circle, for all of these that we visually see, but because this theorem says coterminal angles have the same trig ratios, which I've already alluded to in class, we can expand the unit circle to infinitely many angles. All the angles that are coterminal with the ones on the unit circle. So we're probably going to need a calculator for some of this. So if you want to get up and grab a yellow dog, or you could just stay seated and go to Minnesota. Minnesota. Man, when Minnesota secedes from the Union and takes their calculator with them, we're going to be in a heap of trouble. You know that? Please don't secede from the Union, Minnesota. If you do, leave your calculator behind, please. Loading, please wait, please wait. Good things come to those who wait. Uh-oh. Now it looks like it quit loading. I think Minnesota's on to us. Nope. They let us through. Must be the Wi-Fi. All right. -210. -210 is not on the unit circle that we memorized, right? Because it's a negative angle. But it must be coterminal with 1. In fact, let's take -210 and add a full rotation to it, 360 degrees. That's how we get coterminals, right? We add 360 or multiples of 360 when we're in degree mode. So that's 150. So -210 and 150, are those equal to each other? Say no. Those are different numbers, right? But they are coterminal to each other. Now, you know what is equal? The sine of -210 is equal to the sine of 150. They are exactly the same. Now, what is the sine of 150? Well, See how it's going to be harder to think in terms of degrees because you have to memorize a whole new number. Whereas when it's in radians, all you got to do is memorize the denominator, 6, 4, and 3. 150 is over here, 30 degrees short of your x-axis. So that's going to be your pi 6 reference angle. Okay, that's the same as 5 pi 6. So the ordered pair there is square root of 3 halves, 1 half, and because we're in quadrant 2, it's left and up. So now I got all 6 trig functions. So what's the sign of negative 210? Well, it's the sign of 150. What's the sign of 150? It's the y value, which is what? 1 half. Yeah, there you go. And there's infinitely more angles that are coterminal with it, but negative 210 is what we were starting with. Okay, cool. How about tangent of 16 pi thirds? Well, 16 pi thirds, isn't 16 pi thirds more than one rotation? Yeah. Now, here's what's cool again about radians. Because it's something pi thirds, I know it's going to be coterminal with another pi thirds angle. I know that. I just need to figure out which one within one rotation. So we'll do what we did before. We'll take the 16 and we'll divide it by twice the denominator. That gives us the number of 4 rotations. We'll subtract out the 2, and then we'll remultiply by 16 to get my new numerator. Whoops, I did that wrong. No, I didn't. Did I? I multiplied by 16. I am an idiot. Let's try it again. 16 divided by 6 minus 2 times 6. I don't know why I put 16. I'm getting excited. So 16 pi thirds and 4 pi thirds are coterminal with each other. Yeah, yeah? But their tangents are actually, I keep writing in a highlight. Their tangents are actually equal to each other. So what's tangent of 4 pi thirds? Well, let's go through the process again. Okay, I see pi thirds, and I immediately think 1 half square root of 3 halves. That's just what pops into my head whenever I see a pi thirds. The fact that it's a 4 means that I'm just past 3, I'm just past pi, which puts me in the quadrant what? 3, where they are both what? Negative. They're both negative. So now what's the tangent? Well, tangent's y over x. It's sine over cosine. But it's the numerator of the y over the numerator of the x. So what's negative root 3 divided by negative 1? Just the square root of 3. Not only do the 2's divide out, but here the negatives divide out. Yeah, yeah? Negative over negative is a positive. So tangent of 16 pi thirds is the square root of 3. Yeah, we can verify that if you want. What mode are we in? We're in radian mode. Let's try it. Let's try it. Tangent of 16 pi divided by 3. Let's see what that gives us. Ooh, it gives us 1.73. Let's try tangent of pi fourths. Tangent of 4 pi thirds. What am I saying? 4 pi thirds. Hey, we get the same number. And how about just the square root of 3? Let's see what that gives us. Same number. Go, go, gadget math. Right? Yeah. All right, let's try this one. Cosine of 205,155 degrees. Caliente. That's more than one rotation, right? Let's figure out where it lands. Let's take our big angle, 205,155. It's in degrees, so we'll divide it by 360. We'll subtract out the 569 full rotations, remultiply by 360, and we get 315. Now, 205, 155, and 315 are not equal, but you know what is equal? They're cosine ratios. And where's 315? 315 is over here in quadrant 4. It's the same as 7 pi fourths. So what's the ordered pair there? Well, I think square root of 2 halves. Square root of 2 halves. It's your 45-degree reference angle. I'm in quadrant 4, so to get into quadrant 4, I have to go right and down. Right and down, which means it's positive, comma, negative. Now I'm staring at the ordered pair. You can ask me any one of the 6 trig functions. I look in the front and I see, oh, they're just asking for the cosine, which is what? The x-coordinate, right? Which is square root of 2 over 2. There it is. Boom. Easy. Now, look at this. Let's troubleshoot this. If I type in cosine of 205,155, I get this answer. And if I type in cosine of 315, I get this answer. And if I type in the square root of 2 over 2, I get this answer. What the crap? Ah, very good. Don't blame Minnesota. Blame yourself. We're supposed to be in what mode here? Degree mode, and I'm stuck in radian mode. So it only matters what mode you're in case you're wondering, when does it matter what mode we're in? Whenever you hit the sine, cosine, or tangent button for any reason, you need to make sure you're in the right mode. One of those three numbers is actually correct. Which one's correct?
The
Which of those decimals? Negative 0.9, 0.6, or 0.7 is actually
point
correct? The 0.7. Yeah, because we typed in a direct ratio. In fact, if you want to verify, you can go back to mode and you can switch to degree, and then you can just come up here and take the cosine of 315, and you get the same answer. And then you can come back up here, take the cosine of that, and get the same answer. So it really matters what mode you're in. Yeah, yeah? When you're using the calculator, when you're pressing sine, cosine, and tangent for any reason. All right. Cosine of 3,655 pi. That's more than one rotation. Let's go. 3,655 divided by what? If it's all over 1, we should divide by what? Twice the denominator, which is 2. 1827 full rotation, so minus 1827. Remultiply by 2, and we get 1. So cosecant of 3,655 pi is equal to cosecant of 1 pi. Even though the two angles are different, their trig functions are the same. Pi is a quadrantal angle. It lands over here. What's the ordered pair at pi? Negative 1, 0. Yeah. And I want the cosecant. The cosecant is the reciprocal of the sine value, which is the y value. What's the reciprocal of the y value? The y value is 0, right. So the reciprocal of 0 is d and e. Right, good. All right. Cool beans, huh? Now, those are going to be exact values because we have radicals. The unit circle, as good as it is, sure misses a lot of angles, doesn't it? Like, there's not a 31 degrees on here. We don't have the trig functions for 31 degrees. We don't have the trig ratios for 73.215 degrees, right? There's a bunch of angles that are missing. We're only hitting the special angle. So what happens if we want to know the trig function of an angle that's not on the unit circle? Put it in the calculator. Now, it's not going to be nearly as fun because the calculator just spits out the answer. We don't have to think too much, but we have to think a little. We got to get it into the calculator correctly. So the number one thing that you want to consider when you're doing a calculator problem is check your mode. Check your mode. Let's do part A. 327, 15, 12. That's not on the unit circle. That is in quadrant 4, so I know the sign at least is going to be what type of number? Positive or negative? In quadrant 4. Should be in quadrant 4, the sign, the y is negative. Should be a negative number. Yeah. Let's go ahead and check our mode. What mode should we be in here? What does it say? We're in 327 what? Degrees. All right, I'm already in degrees. That looks good. Now, we already learned how to convert from DMS to decimal degrees. We could do it in the problem. Watch this. You can hit sine of 327 plus. And then how do I convert 15 minutes to degrees? Divide by 60. Very good. Plus, how do I convert seconds to degrees? Divided by 60 twice or 3,600 once. There you go. I like the simpler one. Divide by 3,600 once, which is 60 squared. You don't have to convert it first and then take the sign of it. You can take sine of and just type it in. Your calculator knows what to do. Negative 0.540 or negative 0.541 if you round. I'm just going to truncate from here on out. But if you do truncate, you do need that 0. And it was negative, just like we thought. Yeah, yeah. Not as fun, is it? Not as fun. All right, secant of 45. What mode should we be in? Is that degrees? Just because we have a 45-degree angle that we memorize? Does that mean that every time we see a 45, we're thinking degrees? Do you see a degrable there? I don't either. So guess what mode we're in? We're in radian mode. That's 45 radians, folks. So you go to your mode, make sure you're in radian mode now, hit enter. And now, how do we type in secant? We don't have a secant button. Now let's talk about inverse. When you take the inverse, remember, you're going backwards. You're taking the inverse of a ratio to find an angle. So we're not going to do the inverse, but we will use, yes, there's the R word. What do we say up here? Cosine is the reciprocal of what? Secant, right? Secant. So that's how we're going to do it. So let's write it on the paper. Secant of 45 is 1 over cosine of 45. And now I've given myself something I can type into the calculator. Alpha x, 1 over cosine of 45. I already checked my mode, so I'm not going to wreck myself. And we get 1.903 or 1.904. There you go. All right. How do we type in cotangent if there's no cotangent button? It's the reciprocal of which one? Tangent. So let's write that out. It's 1 over tangent of 201.53. Not the inverse tangent. We don't hit second tangent. It's 1 over tangent. So alpha x, 1 over tangent of 201.53. Yeah. Yeah, I was going to type it in and write down the answer, but then say, is that correct? What do we know about the sine? Where does 201 degrees live? In the third quadrant. What should tangent be in the third quadrant? Positive or negative if they're both negative? Negative y over negative x. It should be positive, right? So I got a positive answer, so there's nothing to alarm me. But what did I not check beforehand? I did not check my mode. So if that had been like a negative number, I would have caught it. But I didn't catch it. So what should be always the first thing you do when you're doing these types of problems? Check your mode. Make sure you're in degrees or radians. Okay, notice I got a different answer. This one is not right. If we're taking a test on our next test, and I give you a question like this, I could give you a simple question like this on the multiple choice. Guess what answer choice A might be? 1.978. Is that evil? I don't think so. It's just being a math teacher. Be in the right mode. Be in the right mode. I was trying to find the best laugh, and I kind of went to like 2 or 3 different types, and that one laugh. Maybe you can combine them all. The one laugh like that. 19 pi fifths. I think that's more than one rotation, isn't it? Yeah. Let's is that a unit circle ratio? Something pi fifth? Did we memorize pi? No, we didn't. So let's just go straight to the calculator. Now, I don't have a cosecant button, so how am I going to type that in? Cosecant's reciprocal of what? Sine. So 1 over sine of 19 pi fifths. There we go. Alpha x. What mode should I be in? Let's check it first. Radian. I better get radian mode first, not second. First. And then I can do alpha x 1 over sine of 19 pi divided by 5. And we get negative 1.701. There you go. The calculator questions are not as fun because you don't have to think as much. But boy, there still is thinking, right? Am I in degree or radian? If I don't have that button, how do I type it in? It's the reciprocal. Okay. All right. Any questions on that? All right. We're done with the calculator. Your worksheet's due tomorrow. Worksheet is due tomorrow. Worksheet due at 9 a.m. Wednesday. Hopefully you're almost done with it if you're not done with it already. All right, let me show you what your quiz tomorrow is going to look like. I'm not going to put it into Canvas, but if you want, you can go to your favorite website, which is not Kahoot. Your favorite website, hopefully, is Korpi's World. And go to Pre-Cal Matters. Pre-Cal Matters, that's Korpi's World Pre-Cal Matters. Scroll down here to 5.3. 5.3. Look right above 5.3. There's 2 different 5.3s. There's all kinds of stuff in 5.3. But do you notice on 5.3, right below circular trig functions, it says blank unit circle? You see that? That's on my website, korpisworld.com. Pre-Cal Matters, blank unit circle. When you click on it, it gives you a blank unit circle. It has a dot around the circumference at every point that was on the one that we generated. This is an old document. I'm actually going to hand you a photocopy of this very page with all the speckles on it and everything. This page is very special to me because this is the exact quiz used by Mr. Peck back in the day, 35 years ago, when I was sitting in his class and he gave me the unit circle quiz. This is his handwriting at the top, the name and the unit circle quiz. The print that says write the angle, I added that. But this was the exact paper. So I'm kind of fond of it. I'm a little sentimental to it. And you'll get to take your unit circle quiz on the same piece of paper that I did, okay, on the same diagram. Now, oh, I made 100. Yeah, and y'all will make 100 too. So here's what I want you to do. Go ahead and load this, export it into Notability. We're going to actually do it together here. I'm going to create a new note, and let's see, I'll do it in pre-cal notes, and we'll call it blank unit circle. Okay, import. All right, so here's what we're going to do. I'm going to time ourselves. You have 5 minutes tomorrow, 5 minutes to fill this entire thing out, okay? And I'm going to show you that it can be done because some people are like, that's a lot of information for 5 minutes. Well, it is, but if you don't mess around and you know what you're doing, it's plenty of time to get the job done, okay? So, does everyone have it downloaded, uploaded into Notability? I'm going to time it starting right now. The first thing that I would recommend that you do is get your quadrantal angles out of the way. This is the point 1, 0. This is the point 0, 1. This is the point negative 1, 0. And this is the point 0, negative 1. These are the ones that most people forget. They leave them off accidentally. So I like to do them first. Now, let's do the angles. I have to do 2 different sets of angles at 0. I have to do 0 radians and 0 degrees, coterminal with 2 pi radians and 360 degrees. This is the only angle where you're going to write 2 different sets. Everywhere else gets 1 set of angles, okay? But you're going to have to write both of those. All right, up here, this is 90 degrees and pi halves radians. Over here on the left, it's 180 degrees and pi radians. And then straight down here, of course, is 270 degrees and 3 pi halves radians. There you go. We finished the quadrantal angles. All right. Now I like to do all my 30-degree angles, okay? So if I come over here, 30 degrees, this ordered pair is going to be square root of 3 halves, 1 half. Over here at the next dot to the bottom, it's negative square root of 3 halves, 1 half. This dot right here is negative square root of 3 halves, negative 1 half. And then this dot over here is square root of 3 halves, negative 1 half. Okay? So I like to do all of my pi 6 angles first, or after the quadrantal angles. All right. So now I write it down. This is pi 6, or 30 degrees. This one is 5 pi 6, or 150 degrees, 30 degrees short of 180. The next one is 7 pi 6. See how the radians are actually easier? 7 pi 6, which is 180 plus 30, that's 210. And then over here in quadrant 4, that's 11 pi 6. And then 30 degrees short of 360 is 330 degrees. I am now done with all of my 30 degrees or pi 6 reference angles. All right, let's just keep walking up now. My pi fourths is square root of 2 halves, square root of 2 halves. I'll get all the ordered pairs first. This is negative square root of 2 halves, positive square root of 2 halves. Down here in quadrant 3, they're both negative. Negative root 2 over 2, negative root 2 over 2. Down here we get positive root 2 over 2, and then negative root 2 over 2. So it's just the way I do it. I get all the ordered pairs first. Then I come back with the angles. This is pi fourths, or 45 degrees. Again, you're going to see that you like the radians better. In quadrant 2, it's 3 pi fourths. And now you have to do a little math if you don't have it memorized. What's 180 minus 45? It's 135. Down here in quadrant 3, the radians is easy. It's 5 pi fourths. But now you got to do a little math. What's 180 plus 45? That's 225. And then over here in quadrant 4, sorry, it's 7 pi fourths. And then you do a little math and you get 315 degrees. All right. Anyone bring a ham sandwich for lunch today? Ham sandwich, anyone? That used to be a real popular meal. Now a lot of people just bring Lunchables or leftovers, right? But man, back in the day, it was all about the ham sandwich and a bag of Fritos or Doritos. All right. Yes, you will. Make sure you have the degrubble. Good question. All right, let's do the next one. It's your 1 half square root of 3 halves. So these are the ones that are all closest to the y-axis. Negative 1 half square root of 3 halves. And then straight down here, we're going to have negative 1 half negative square root of 3 halves. And in quadrant 4, it's positive 1 half negative square root of 3 halves. So I got all of the ordered pairs listed. Now I just got to come back and do the angles, okay? This is your pi thirds reference angle or your 60 degrees reference angle. Pi thirds or 60. So again, you'll like radians. In quadrant 2, it's 1 less than the denominator, so it's 2 pi thirds. And now a little bit of math. What's 180 minus 60? That's 120 degrees. Okay, straight down here near the y-axis, we get 4 pi thirds. And then 180 plus 60 is 240 degrees. Yeah, you got to do a little math. I don't like doing that. And then over here in quadrant 4, you're going to have 5 pi thirds. And then the next one is going to be 60 degrees short of 360, which is 300 degrees. And we just finished right there. We just finished. Guess how long that took us? Siri thinks I'm trying to talk to her. That took 4 minutes and 34 seconds. So it took us a little bit longer this period than last period. But you know what? I stopped to talk about ham sandwiches in the middle. And tomorrow on the quiz, when you fill this out, you don't have to stop to talk about ham sandwiches. And you won't have me slowing you down either. Okay? Is it possible to practice and rehearse for this so that you can get it in 5 minutes for tomorrow? Yeah, where can you go to get a practice thing? Oh, yeah, it's right here. We already got it, right? You can just duplicate it or clear it and try it again. Now, if you want to print it out and try it on actual paper, because you're taking it on paper tomorrow, and use an actual pencil instead of your finger, you don't want to be caught off guard tomorrow when you have a pencil in your hand like, oh my gosh, I am used to using my finger. Oh, and now you're gonna so practice the way you're gonna play. 4 minutes and 34 seconds, you'll have 5 minutes. It's easy. Thousands and thousands and thousands of students before you, including me, have done this. Okay. Now we got 5 minutes left, don't we? Yeah. Let me show you. This is what we're doing tomorrow. Tomorrow it's a one-time only fill in the unit circle. That's it. That's Wednesday. On Thursday, we begin taking our what I call using the unit circle quizzes, which is really what it's about. It's one thing to be able to fill in the unit circle, but what we're really after is can you use it? Okay. So where do you go to practice that if you want? Well, you go back to Korpi's world. Go back to Korpi's world. Got to wait for the internet. Okay, go back to Pre-Cal Matters. Now, if you go back to 5.3, notice right below developing the unit circle video, it says using the unit circle practice. You'll see that? Using 5.3b, using the unit circle practice. There's a worksheet and there's also a key so you can check yourself. So go ahead and download this worksheet if you want. I give you 6 sets of 10 on using the unit circle, 5.3b. I'm going to upload this also into Notability. I'll create a new note, and I'll do it in Pre-Cal Notes. Yep, there we go. Done. Using the unit circle, 5.3b. Now, let me show you what your quiz on Thursday will be. Thursday, you're going to get all sine and cosine, just like set 1. All sine and cosine, none of the other 4. And you're going to have 10 minutes to fill this out. 10 minutes, okay? On Friday, is that right? Wednesday? Yeah, on Friday, you're going to have 10 minutes, but now you're going to have all 6 trig functions, all 6 of them. And then every day after that, you're going to have all 6 trig functions, and the time gets shorter. 8 minutes, 6 minutes, 5 minutes, 4 minutes, 3 minutes. Now, you don't have to follow the guidelines of these. This says doing 6 minutes, doing 6 minutes. I just put that there to overtrain you, okay? But everything except set 1, which is all sine and cosine, has mixed sine and cosine and tangent and secant and cosecant and cotangent, all 6 of them, okay? But we're going to start off Thursday like babies, okay? Let's see if we could do this in the time remains, or at least start. Okay, so this is your Thursday quiz, not tomorrow, but this is your Thursday quiz. 10 minutes to do these, a minute per question. You have a lot of time. What's sine of 5 pi 6? Well, you almost have time to write the ordered pair out. If it's sine of 5 pi 6, you know the ordered pair is some type of square root of 3 halves, some type of 1 half. 5, 6 puts you in quadrant what if 5 is less than 6? Quadrant 2, where you're left and up. There's your ordered pair. What's the sign? It's the y value. It's 1 half. Do you have to wait the full minute to move on to question 2 on Thursday? Nope, you just boogie. You mosey right along. Cosine of 7 pi 6. Again, I see pi 6. That's square root of 3 halves 1 half. The 7 is bigger than 6, so I've rotated past pi into quadrant 3, where they're both negative. You want the cosine, that's the x-coordinate. That's negative root 3 over 2. Easy peasy, lemon sneezy squeezy, right? Next one. Sine of 3 pi fourths. Pi fourths. I'm thinking square root of 2 halves, square root of 2 halves. 3 is less than 4. I'm just short of pi. I've landed in quadrant 2. How do I get to quadrant 2? I go left and up. So it's negative positive. You want the sign? Well, that's just the positive root 2 over 2.
Well, if you count it wrong, if you get the wrong sign on it.
Yes. If you put a plus and it's supposed to be negative, it's wrong. Yeah. It's got to be exactly correct. All right, cosine of 11 pi 6. Pi 6 again, that's square root of 3 halves, 1 half. 11 is in quadrant 4. To get to quadrant 4, I go right and down. So it's positive, negative. You want the cosine, so it's positive root 3 over 2. So on and so forth. You can work through the rest of this if you want. The key is posted next door to it on the website. And you can even practice doing all 6 of them if you want in 10 minutes, okay? You can follow the time that I give you here. We will do one ghost pepper challenge towards the end, which is an optional quiz. If you can do 10 of them in 1 minute, I'll replace your low grade on one of the others, okay? But that's it. That's unit circle. That's what it's all about, man. It's a lot of fun. I think you would agree. You can't disagree.